Welcome to this lesson on algebra, variables, and expressions. Please make sure you have these notes in front of you so we can begin our lesson. The learning objective for today says, I can evaluate algebraic expressions. So let's talk about the vocabulary on the left-hand side of our notes. The first word is called variable. A variable is a letter that can represent any number. So for example, x is a variable. It could mean any number in the world. The second vocabulary word is called algebraic expression. And an algebraic expression consists of numbers, variables, and operations. So this is an example of an algebraic expression. It doesn't have an equal sign. It has numbers, it has a variable, and it has an operation sign. Alright, so let's go ahead and talk about the key concepts on the right-hand side of our notes. So there are many different ways to show multiplication. Here's one example. You can say 5 with a dot and an x. This means 5 times x. You could also show it like this. 5 parentheses x. This also means 5 times x. And there's another way you can show multiplication. You can show it as 5 and the x standing right next to it. This also means 5 times x. So the most common way you're going to see it is shown in this form right here, 5x. That's the algebraic expression. So what happens if I say x is equal to 7? One thing that people do is, if I have 5 and x, they replace the x with 7, but they make it look like 57. That is not the correct way to do it. The correct way to do it is you take 5 times the value of x, which is 7, and then you just sit there and multiply it. So in this case, if x was equal to 7, my algebraic expression would equal to 35. But variables make your algebraic expression change. So let's use these key concepts to solve the following examples. Example 1 asks us to evaluate x minus y if x equals 64 and y equals 27. So the first thing we want to do is we want to substitute the numbers that we have representing the variables. So for example, x we know is equal to 64. So in my expression, I'm going to substitute 64 wherever I see x. So 64 takes the place of x. Then I'm going to drop down my subtraction sign. And I know that my problem says y equals 27. So I'm going to substitute 27 in for y in my expression. Now I can simplify this using the order of operations. Since we only have subtraction left, I'm just going to subtract. And 64 minus 27 is equal to 37. So for example 2, they ask us to evaluate 6x if x equals 1/2. So we know the value of x. X is equal to 1/2. They're giving us the algebraic expression, and I know this is an algebraic expression because it has a variable and it has a number. And remember, whenever the variable and the number are standing next to each other, we're multiplying it. So I'm going to rewrite 6, and I'm going to write a multiplication sign right next to it, because when they're standing next to each other, that means they're multiplying it. I know the value of x is 1/2, so I can substitute 1/2 wherever I see x. Now I can start simplifying. I know that I can make 6 into a fraction by placing it above 1, and I can multiply that by 1/2. Now I can just multiply my fractions. I know that 6 times 1 on the numerator is 6, and 1 times 2 on the denominator is equal to 2. When I simplify that further, I get 3 as my answer. So pause the video, complete these got it problems, and we'll discuss the answers in class tomorrow. Notice this got it problem has 4 got it problems, A, B, C, and D, and I know for a fact that you are all going to do very well on them. So for example 3, they say evaluate 5t plus 4 if t is equal to 3. So I know that the value of t is 3, and our algebraic expression is 5t plus 4. And once again, you know this is an algebraic expression because it has operation symbols, it has variables, and it has numbers. So what we're going to do is we know that whenever the variable is standing next to a number, they're multiplying. So I'm going to write 5 multiplied by parentheses, plus 4. Inside the parentheses, I'm going to place the value of t, which is 3, inside of my parentheses. Remember, whenever they're standing next to each other, that means you're multiplying it. So the parentheses are saying that they need to be multiplied. I can solve this problem now using order of operations, or using Gemma. This problem does have grouping symbols, but there's nothing inside of the grouping symbols for me to do, so I'm not going to use grouping symbols. It doesn't have any exponents, but it does have multiplication. I'm going to multiply the 5 times 3, which becomes 15, and then drop down the rest of the problem. It doesn't have any division, but it does have addition. So I'm going to add 15 plus 4, and I get 19. And 19 would be my correct answer. For example 4, they're asking us to evaluate this algebraic expression, which is 4x to the second power, if x is equal to 1/8. So they're telling us that x is equal to 1/8, and in our algebraic expression, we can just rewrite it. So 4 parentheses in to the second power. Inside the parentheses, I'm going to write 1/8 because I'm going to substitute 1/8 wherever I see x. Okay. Now I want to use Gemma to further simplify this problem. So this problem does have grouping symbols, but you can't really do anything with the 1/8 inside of it. So I'm going to move on to exponents. This problem does have exponents. So I'm going to solve the exponents first. I know that 1/8 to the second power. Please don't multiply 1/8 times 2. That's repeated addition. What you need to do is you need to take 1/8 times 1/8 and multiply it that way. So I get 1/64. So the value of 1/8 to the second power is equal to 1/64. Drop down my parentheses and place the 4 next to it. And remember, whenever there's parentheses, you're multiplying your two numbers. So now I do have addition. Now I do have multiplication. So I'm going to circle multiplication. I'm going to multiply these two. 4/1 multiplied 1/64. You can make your life a little easier by cross-canceling. So 4 goes into 4 once. 4 goes into 64 16 times. So my answer becomes 1/16. So the simplified form of this answer is 1/16. So pause the video and complete these got it problems, and we'll discuss the answers in class tomorrow. Notice there are 2 got it problems on this slide, got it problem E and got it problem F. Example 5 says the expression for the area of a square is s to the second power. S represents the side of a square. So if we look at the square below, we know that the square has 4 equal sides. This problem wants us to find the area of the square below. So I can write it like this. S to the second power is written in exponential form. I can expand that out or write it in factor form by writing s times s, and I can solve my problem from there. Remember, the area means the space inside of the shape. So everything that I'm coloring right now is the area of the square. So I'm going to write 12 to the second power because 12 is how long one side of the square is. I'm going to multiply 12 times 12. So when I multiply it out, I get 144. Now because this is a problem about area, I have to make sure I put my square units. So this is 144 centimeters to the second power. So that's the area of this square. For example 6, it says the expression for the perimeter of a square is 2 times L plus 2 times W. So think back to your PE class when your PE teachers say run the perimeter. They're asking you to run around the field. So here the perimeter means everything around the square. So I've got 2 lengths, this is the length, and I have 2 widths, which is the reason why I have 2 lengths plus 2 widths as my expression. So if my expression for perimeter wants me to add up all the different sides, I can write 2L plus 2W, and I can go ahead and start plugging numbers into this numerical expression. So 2 times L, well, the L is worth 12, plus 2 times W, the W is worth 12 as well because it's a square. All sides are equal. Now I can go ahead and multiply 12 times 2, that becomes 24. And I can multiply 12 times 2, which is 24 again. When I add those two together, I get 48. But because this is dealing with perimeter, I have to write 48 centimeters. In the last problem, I wrote centimeters squared, but that's because it was area. This is not area, so I'm going to just keep it as 48 centimeters. So the perimeter around the entire square is 48 centimeters long. For example 7, it says the expression for the volume of a rectangular prism is B times H times W. Well, the B stands for base, so this would be the base of the object. The H stands for the height of the object. And the W stands for the width of the object. So there are three different dimensions. So if I use my algebraic expression, base times height times width, I can just go ahead and substitute the numbers that they give me into this algebraic expression. I know that the base is worth 6 times the height, which is worth 8, times the width, which is worth 2. Now, since I have these numbers, I can just go ahead and multiply them. 6 times 8 gets me 48. Drop down the times sign and the 2, and multiplying 48 times 2 gets me 96. So because this is volume, volume has three dimensions. Remember, it has the base, the width, and the height. That's three dimensions. So because it has three dimensions, I have to write centimeters to the third power. And that's the answer for this problem. So pause the video, complete the got it problems, and we'll discuss the answers in class tomorrow. Notice there are two got it problems on the slide, got it problem G and got it problem F.